Hi guys. Okay, we're gonna try this. So, this is a pretty hard problem, but we're gonna get through it. A positive integer n has exactly 2025 factors, including 4 distinct prime factors, and ends in 4 zeros. The number n over 10 factorial is an odd integer that is divisible by 21, but not 245. Find the largest possible integer value of k such that 3 to the k is a factor of n. Okay, so if it ends in 4 zeros, and we know that it is n is equal to 2 to the a times 5 to the b. A is greater than or equal to 4. B is greater than or equal to 4. If a is greater than 4, if a is greater than 4, then b can't be greater. Okay. If it has 2025 factors, there's a formula for factors. I believe it's, take all the, if you take the prime factorization, it's going to be like a plus 1 times b plus 1, I think, dot dot dot, I think. We have 2 to the 2 times 3 to the 1. The different factors, this is going to be 12. The different factors are 1, 12, 2, 6, 3, 4. 1, 2, 3, 4, 5, 6. So 2, yeah, that makes sense. So, 2025, where's my cursor? 2025 is going to be equal to, something, a plus 1 times b plus 1 times other stuff. Okay. Cool. I'm gonna pause this because my cursor is being weird. Okay, I'm back. So, if we were to continue, we know 2025, I think we did this before, is equal to 45 squared, which is equal to 3 to the 4 times 5 to the 2. Yeah. So this, this needs to be equal to this, which means so I was thinking they're gonna both have to be 5 because they're both greater than 3. But the thing is, that can't be possible. One has to be, 1 is greater than 4. The other has to be greater than. I mean, it could end in more than 4 zeros, I guess. It doesn't say exactly 4. You know it ends in 4 zeros. Okay, I'm looking too much into that. N over 10 factorial is odd. So 10 factorial divides n and takes out all the factors of 2. And then, so that means that 2 does not divide this. So 10 is equal to 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10. We have to have this 2, so we have 1, 2, 3, 4, 5, 6, 7, 8. We have 2 to the 8. So that's going to be our 9. That's one of our 9s. So 2025 is equal to 8 plus 1, which is 2 to the 8. And then what else? We also have okay, so it's if it's divisible by 21, 21 is 7 times 30. 245 is 5 times it'd be 5 times 410. No. What? 5 times 49. So 5 times 7 squared. Yeah. So we know it's times 7 to the 2 because it's divisible by 21 but not by 7 squared. So 7 to the 2 times 2 plus 1, which is 7 to the 2. So right now we have 9, 3, we have another 3 and 2 more 5s. Here we also have, our other thing is 5 we have, and then we have 3. So if it's divisible by, oh shoot. Shoot, that might not be correct. Because the 5 could cancel it out, we don't know. Huh. Well, okay, if it ends in... It's true. If it ends in 4, 0. If it ends in 1, 0, we need 1 factor 5. 2, 2 factors 5. 3, 4, 5. Including 4... Oh, it has 4 distinct prime factors. Oh. So n is going to be equal to 2 to the... What did we determine? 8? Times 5 to the a times 3 to the a, 3 to the k, I guess, times 5 to the a times 7 to the b. So if this is 2 to the 8, we want k to be the largest it could be. K can be 2025 divided by 9 is, it would just be 9 times 25. 9 times 25 is 225. Let me check. Yeah, 225. So 225 is going to be equal to k plus 1 times a plus 1 times b plus 1. Okay, we know, so the different things that can, 3 factors, 20, this is 3 squared times 5 squared, so it could be 25, well, we know a has to be greater than, or has to be greater than 4, greater than or equal to 4. So the smallest we can make it is, we could have 1, 20, 225, I guess. We could have 1, 5, 45, 1, 15, 15. We could have a lot of things, really. We just know that this has to be greater then the fifth one. So this is 3, this is 5, this is 7. 5 has to be greater than 4. So our options are, what can we do with just 5 and 3? We could do 9, 15, 45, 135, right? 225. 3, if we have 3 squared, is that 3 squared times 5 is 45, 3 squared times 20, yep. 3 times 5 is 15, 3 times 5 squared is, 75 too. 75. 135 is that included? 135 is 9 times, 14? No, 9 times 15, which is an extra factor of 3 that we don't have. Okay. So if this is B, or if this is A, what else are our other constraints? If it's divisible by 21 but not by 245, so if it has one factor here, 2, 3, 4, so 3 is greater than 4, it's greater than 5, so k is greater than or equal to 5. So if k is greater than or equal to 5, wait, what? I guess 5 could also work here, because it's that plus 1, so 5 could also work. If k is greater than or equal to 5, then, so can we have, for k, we could have, oh my gosh, my brain is not working right now. And then if it's divisible by 21, so it includes at least 2 factors of 7, so b is greater than or equal to 2. But not 245. So 245 is 5 times 49. So, so either b is greater than or equal to, is less than 3, right? 7 here, 2 sevens. Or, we don't have the 5, so then that would be 2, 1, 2, 1, 2, 3, so then either that or, a is less than or equal, is less than 3. 1, 2, and then we have 3. Our constraint is a, yeah, so b is greater than 3. Or is b is equal to 2 or 3. So if b is equal to 2 or 3, we know b can't equal 3, b has to equal 2, because we have to have a factor of 3. So b is equal to 2. So b is equal to 2. So then 2025, or 225 over 3 is equal to k plus 1 times a plus 1. This is equal to 60, 15, 75 is equal to k plus 1 times a plus 1. We know that a has to be greater than or equal to 4. We know this is 3 times 5 squared. So 3 is not going to be a factor because k also has to be pretty large. So it's either going to be 3 times, not 3 times 25, 15 times 5, 25 times 3 doesn't work, 75 times 1 doesn't work. So I think k, the largest it could be is 14. Right, because k has to be, I think that works, because then that'd make a 4. Okay, let me check, I think that's the answer. Yep, this is right, and they did it pretty much the same way as I did, so cool. Thank you guys for watching, I'll see you guys tomorrow. Bye.